looking at everything from a number 1 all the way to a number 10. All right. You do know we have 10 questions to deal with. So let me say again, as soon as I come, hit the likes button. All right. All right, here it is. This question says that using a calculator or otherwise, find the exact value of 8.9 plus 31.6 all over 0.75 multiplied by 5.4. What I'm going to do is to work out the response for the top, then work out the response for the bottom, and then I divide. So for the top, we use our calculator. And that's what the number 1 questions are about. Are you able to use your calculator well? So we're talking 8.9 plus 31.6, and I'm getting 40.5. So 40.5 must be divided by 0.75 times 5.4, and this actually gave me 4.05. Finally, we're gonna divide 40.5 by 4.05, and our answer is 10. All right. So our answer is 10 right there. All right, let's go to the next question. So this other question here is actually saying we want to find the value of 3.9 tan 18 degrees, correct to 1 decimal place. Again, this is a question that wants to know how well will you be able to put together using your calculator these responses. So we're just going to put these on the calculator as is. 3.9 times the tangent of 18 degrees. If you put that on your calculator, make sure that your calculator is in degree mode as well. You're going to get 1.267, and it goes on. But they ask us for 1 decimal place. Therefore, we're going to mark this spot and then look to the right. So you could say that number 6 is in the 5 to 9 category. That means the spot 2 will go up by 1. So the answer to 1 dp is 1.3. There you have it. So we have 1.3. All right, guys, I'm expecting you to put out your answers, right? Put out your answers. All right, put out your answers. And everybody that is here, please hit the like button, please. All right, so that's that. Here's a problem that we want to work on now, right? So I want everybody to look at it, read it, and try to put it together for yourself before I actually start doing it, right? So try to put it together for yourself, and let's see. Okay, Tony Shea. All right, so I'm going to talk this one through, everybody. Right. So this one says the diagram below shows a quadrilateral with the length of its sides written in terms of x. So we have one side that says, I'll mark over it. It says 15 minus 2x. Then we have 3x minus 7. 2x plus 5, and then 2x minus 1. So those are the sides. They are written in terms of x. The question is saying, write an expression. I'm reading here now. Write an expression in terms of x for the perimeter of the quadrilateral. Express your answer in its simplest form. So we're going to go for the perimeter. The perimeter, as you all know, is dealing with the distance along the boundary. All right. Some people say around the boundary. All right. So we're talking about the distance along the boundary. Therefore, we are going to be putting together 15 minus 2x. This is that one. Then this one, I'm going to add that to 3x minus 7. Then I'm going to add that one plus 2x plus 5. Then I'm going to add that one. Let me shift a little bit. Yeah. Yes. Plus 2x minus 1. So there we have all of them. We have our 4 pieces, 1, 2, 3, and 4. So those are the length along the side. But the question actually said, the question said in the simplest form, collecting the like terms. So let me collect the like terms. We have a negative 2x, positive 3x. We have positive 2x. We have a positive 2x again. Then we have a positive 15. We have a minus 7. We have a plus 5 and a minus 1. So I'm putting together the like terms. Definitely you will see that the negative 2 and the positive 2 would have canceled themselves fully. So we are left with 5x for the x's. For the numbers, we'll have 20 minus 8, and that will give us 12. So this is the response for the perimeter. 5x plus 12 in its simplest form. So that's that in its simplest form right there. Now, so you would have gotten your 2 marks for this. The next question is saying that, listen, the perimeter of the quadrilateral is actually 32. So now they're giving us, they're actually telling us that, listen, this quadrilateral that we're dealing with, we know the perimeter of it. The perimeter of this quadrilateral is 32. We have already gotten an expression for that. So the expression for the perimeter is 5x plus 12. All right. So now we can say, listen, 5x plus 12 is 32. So this is an idea because they gave me the perimeter and they asked me to write an expression for the perimeter already. So we're seeing now that we could equate those to help us to solve any problem that we have. The problem that we ought to find, though, says that find the length of the longest side of the quadrilateral. Before we can find the length of the longest side, we definitely need to know the value of x. And then we're going to substitute that value of x for all of those 4 sides to see the longest side. All right. So let us take our time to find the value of x first. Value of x first. Now we're solving 5x plus 12 equal 32. 5x plus 12 equal 32. So I'm going to subtract 12 from both sides here. First move, subtract 12 from both sides. So I'm now left with 5x, which is equal to 20. So 5x is equal to 20, as we could see. Guys, remember, hit the likes. Some of you haven't hit the likes button yet. Could you please do so? Thank you very much. So here it is. So we're going to divide by 5. So we could see where x is equal to 4. So I now know that x is equal to 4. So because x is equal to 4, I could now take that value for x and go back to the quadrilateral to substitute the value for x to see which one of the sides is the longest, because they asked us to prove or to show, should say, which one of the sides is the longest. So all we're going to do here is that we're going to be substituting x where all of these sides are to see. So let me change the marker there. So this one says 15 minus 2x but x is 4, so it's 2 times 4. So basically, we're looking at 15 minus 8, and this is going to be 7. So this side is 7. Here we have 3x minus 7. 3x, but x is 4. So basically, we're saying 3 times 4 minus 7. 3 4s is 12, and if I minus 7, that's 5. So this side is 5. The other side is 2x minus 1. So 2 times x, x is 4 minus 1. 8 minus 1 is going to give me 7 centimeters for that side. The last side I'm going to check now is 2x plus 5, but x is 4, so 2 times 4 plus 5, and this gives us 13 centimeters. After substituting x, we're seeing where we get these as the length of the sides there. So we could say the length of the longest side is 13 after substituting there, right? So what we want to do is just to respond to the question by saying that it is 13. And that's our working there that we just displayed. All right. Hold on, I think I'm running a little bit ahead. Where is it? Okay. So we could just lay this down that the length of the longest side, equal 13 cm. Yeah, so the length of the longest side equal 13 cm. All right. So pay attention, work out the things, guys, and look at it. Try not to make errors. All right, we're going. All right, so we're looking at this other question now. So the question reads, take a look at it. Try to start putting together your working. So I'm giving you a little, a head start to put together your ideas. All right. All right, so we're looking at this now. So it says that I'm reading it from the middle part. So we are saying 2 minus 4x all over 3 is less than 5. Also, 2 minus 4x over 3 is greater than -1. All right. So here is the deal. Whenever you're solving these inequalities, what you want to do is it's basically solve ordinarily. So the aim is to get the x by itself, leave it in the middle. So what we're going to do is to get rid of the things surrounding that. But whenever we see a fraction, we try to get rid of early. So we're going to get rid of this fraction by multiplying everything by 3. Everything, including itself. So we're multiplying the middle piece by 3, the piece on the left and the piece on the right. We did it because we knew that the 3 would have canceled. So the fraction is gone. So when I rewrite this, this is what we'd have. 3 times -1 is -3. Less than, and we have 2 minus 4x, which is less than 5 3s 15. So what we did was to get rid of the 3 by multiplying everything by 3, and it cancels itself in the middle, just in case you're wondering where the 3 has gone. Now, from that, the next move is to get rid of this 2 here. So the positive 2, we're going to subtract 2 from everything. We're going to subtract 2 from the 15, subtract 2 also from the -3. So as you could see, whenever you do it one place, you'd have to do it everywhere for balancing. So let's rewrite what we have. We're having -5 here and that, and then we have -4x less than 13. So this is what we have now. We're not done. We have like a one-shot lead. So we're not done yet. All right. All right. So now here is the thing. We're going to divide throughout by -4. I will say to you, whenever you divide or multiply by a negative number, when you're solving inequalities, you have to turn the sign, or what we say, we flip the sign. So I am aware that at this moment, I have to divide by -4 to solve the problem, which means that when I'm rewriting this, I will turn the sign. So -4 will go under that. I'm going to turn the sign this way, and I'll have -4x over -4. I'll also have to turn the sign this way because I have 13 divided by -4. So let us stop and look at that. The signs that we had looking this way, because we divided by -4, make sure that you flip those signs. So we flip them around. Now let's rewrite our final thing. This is 5/4 greater than, we have the x now, greater than -13/4, right? But -13/4, you know, our 13 divided by -4, if you want to call it that, we'll get -3.25. All right. So we're saying here that x is greater than -3.25, but it is less than 5/4. But I'm going to reproduce 5/4 as a decimal, so we have a very good understanding of what we have. So it's 1 1/4. So I'm going to move this now, 5/4, and I'm going to put 1 1/4 here for it, 1.25. So what I'm suggesting is that, hey, our 5/4 is equal to 1.25. All right. Why? Because I wanna be able to see clearly what we're dealing with here. Now, so this is the answer this is the range of answers that we have to pick what we want. So this is not the answer, guys. You have to pay attention to the question. It says determine all the integers. Very important. All the integers values of x that satisfy this. In other words, what are all the integers values that we could find here? What is an integer? An integer is the whole numbers and the negative of the whole numbers, right? So that's what integers are. So what we're going to do now is to say, guess what? If I'm coming from, based on what we have here, I'm coming from -3.25, and I'm going all the way to positive 1.25. So we are between this. So if you think about this, you'll have -3 there, -2, a 1, a 0, a 1. So these are actually the integer values. There is a -3, there is a -2, there is a +1, there is a -1, should say. Let me write negative there. And then there is a 0, there is a 1. Those are they said all the integers. So the answer is this, that all of those integers are -3, -2, -1, 0, and 1. These are the integers that we're looking for. So here is our solution. So you have to read, because they would have you working out the thing, and if you really don't pay attention, you might not respond to the question. All right, because I've seen a lot of people putting out some stuff and stuff like that. All right, so I'm seeing some good answers coming out, but remember, -3 is a part of it as well. All right, guys, I'm still seeing some persons not hitting up my likes. Come on, guys, hit up the likes so that other persons can find our videos easily when they are searching. All right, so the like helps to promote that visibility of people seeing the videos when they're searching for help. So hit the likes, everybody, hit the likes. All right, so next question. The next question now, we still at some number ones, we soon move out. still have some number ones and some number twos. That's where we are, right? So the next question says use a calculator or otherwise, all right? So we're going to do the otherwise. We're going to work these out. Calculate. So we want to calculate 5.5 minus 5.5 divide by 3 2/3 plus 1 4/5, right? Plus 1 4/5. All right, I will respond to you, Tony Shea. No, you won't flip it. If it is a positive number, we divide or multiply by. No, you don't change it. So that's just the one thing you do differently. When we have a negative number dividing or multiplying and the inequalities are there, we flip the sign, all right? So only a negative number could do that. So a positive number changed nothing. So I hope you get that response. Let me see if I could quickly just say that for you right here. All right. All right, let's go. All right, so what we have here is 5 2 is 10 plus 1, that's 11 over 2. We're converting all mixed numbers to improper fraction. So you know we're going to multiply the denominator by the whole number and add the numerator to it. So we said 2 5s, 10 plus 1, that's 11 over 2. Then we have 3 3s, 9 plus 2, that's 11 over 3. 5 1, 5 plus 4, that's 9 over 5. All right, so then remember the order of operation. We're going to isolate the division part, find out what it is, and then after that, we add the 9 over 5. So we're focusing on the division part. Remember how we divide fraction. When we divide fractions, we change the division sign to multiplication and flip the fraction that comes after it upside down. So then we have 11 over 2, and then we're going to multiply that by 3 over 11. Now I'm seeing where I could cancel 11 here with 11. So I could cancel that. So when I cancel that, I'm left with 1 3 3, 2 1s 2. So I have 2/3 being added to 9/5. Remember, when you're adding fractions, the denominators are different. When it's different, we're going to have to use what is called the LCM. So the LCM is 10. So 2 into the 10 is 5. 5 times 3, 15. 5 into the 10 is 2. 2 times 9, 18. 15 plus 18 is 33 over 10. All right, everybody double check quickly. I'm getting a 33 over 10. All right. All right, so next question says 165 times 0.38 square, giving your answer as an exact value. So we want to get this exactly, but you put this on your calculator and whatever you get is your answer, because that's what this is. It's a 1 mark question. So 165 times 0.38 square, and we get something like 23.826, right? So we get 23.826. 23.826. So that's the exact value that we have. What we're going to do, though, is that exact value will be used to do a number of things, all right? So here is the first task. First task that we're going to be dropping for that. So here is the first task. So the first task says write your answer. So the answer that we got above was actually, let me write it here, 23.826. We're going to write that correct to 2 decimal places. Remember though, when you're doing decimal places, 2 decimal places, this number 2 is occupying the second spot. As soon as we have identified the digit that is in the spot, the next thing that we want to do is to look to the number to the right of it. And that number is a 6. If the number to the right is a 6, that means it's in the 5 to 9 category. Because we have 2 categories. We have 0 to 4. And with 0 to 4, if the number to the right is between 0 to 4, you leave the spot. But if it is between 5 to 9, you add 1 to the spot. Hence, the answer is 23.83 to 2 decimal places, because this will be rounded up. Now, we want to work this to 3 significant figures now. The same thing that we have here, we're going to put it to 3 significant figures. Now, all digits are significant, except 0, which may or may not. There is no 0 in this figure, so we don't have anything to be thinking too hard about, right? So then, we're saying, guess what? 3 significant figure. What is occupying that 3rd spot? Number 8, because all digits are significant except 0, which may or may not. And the significant figures run from left to right. So the first significant figure was a 2, then a 3, then a 8, then a 2, then a 6. And it's 5 significant figures there. We're looking at the 3rd spot. So the 3rd spot, we realize that it's the 8. Now, since it's the 8, then you're going to have to look to the number to the right of the 8. So let us see what is to the right, number 2. And number 2 is in this category. It's in the 0 to 4 category, which means that we're going to have to leave the spot alone. So it's 23.8 to 3 significant figures. All right, let's go. We want to round this up to the nearest whole number. You could see for yourself. 23.8. 23.8. So let's go back to it. All right, let's go back to it. To the nearest whole number. This is the decimal section. Yeah? So when we talk about whole number, we're referring to this part here, 23. So you're looking at the 3. See, it's the last piece of whole number in the 20s, 20 in this figure, I should say. So then you look to the right and it's the 8. Then you're like, oh, that means that go up from 23 to 24. All right. So to the nearest whole number, 23.826 becomes 24. All right. Not bad. Not bad. Not bad. Very good, very good, very good. All right, so now we're looking at a simple interest question. So I made sure that I got some of those questions there, so everybody could actually see what's going on. All right, so we have some simple interest question going on right there. And this question reads, it says that Mr. Adams invested $5,000 at the credit union and received $5,810 inclusive of simple interest after 3 years. In other words, you would have went into that credit union, you invested a $5,000. After 3 years, when you came back, you realized that you have $5,800, because they did say that $5,008 is inclusive of that simple interest after 3 years. So determining the simple interest earned. Now, the simple interest would have been the change or the shift in your money that you left. So you would have known what you left, and then you would be aware of what you're seeing now. For example, I am seeing $5,810, but I knew I left $5,000 there. So that increase would have to be the interest, all right? So that increase that I saw of $810 would have been the interest that I've earned, right, over that 3 years. And this is not 1 year interest. This is the 3 years interest because we were told that is 3 years. All right. They want us to work out the annual interest rate paid, right? The annual interest rate paid. So they want to know the rate. Now, let's look. Let's write down some stuff. I have my simple interest. It is 810. I have my principal, which would have been the money that I invested. It's $5,000. And the time of my investment, T, was actually 3 years. So I have those information. They're asking me now to find R, which is the rate. Okay. Remember though that this formula that we have is a formula for everything. There are many ways you could work this out. The simple interest formula says that the interest is P times R times T over 100. I'm going to work it this way, and then I'm going to work it another way for another set of people. So in this case, I'm suggesting that you could substitute everything that you have from your interest to your principal to your time, and then search for R. So then let's see what I'm saying. Interest was 810. I'm putting it out there. So interest, which is the 810, is equal to my principal, yes, 5,000, times the rate that I don't know yet, times the time that it took, which is 3 over 100. What I did here is just to simply substitute. I am substituting what I know, all right, in the regular formula, and then we work it down. You could work it, you could see 2 zeros cancel right there. So you'll actually have 810, which is equal to 50 times 3, yeah? And so we'll end up with 150 R, all right? So we have 150 R right there, right? Now let's see. So the R is gonna be 150 divided by 150 there, divided by 150 there. So 810 divided by 150 is going to give me 5.4%. So my rate is 5.4% per annum. So that's the rate that we're getting, right? 5.4% per annum. All right. All right, guys, some of you are there. You haven't hit the likes yet. Hit the likes, please. All right. That's one way. Let me work it another way, because I know that some persons might have approached it like this. So I'm going to put another solution here. All right. So you might have had a formula for rate by itself and said rate is equal to 100 times the interest over P times T. So this is another way we could find the rate. All right. And then we're going to do some substitution here. 100 times the interest, which is 810, divided by the principal, which is 5,000, times the time, which is 3. So if you want to do some canceling, you can. So these zeros could cancel that. So we actually have 810 at the top over 150. You do realize it's the same numbers coming back, 5.4%. So the rate is 5.4%. So it's up to you if you want to work it like the original formula and substitute, or if you claim that you know your rate formula by itself, you set it up or transpose for rate and work it. I promise you will get the same answer, and it doesn't really matter. All right. Okay, KK Powell, good afternoon. All right, let's now look at the next question. It says the length of time. So we're supposed to determine the length of time. The length of time it will take for Mr. Adams' investment to be doubled, right, at the same rate. Now, they are saying that the rate is the same. So we're talking about the rate, which is 5.4. So R is 5.4, they are suggesting. All right. Now, its principal is 5,000. There are many ways you could work that. I'm just writing out some information give to us here. All right. The time we don't know because they are asking for it. All right. Now, what we want to read out now, or what we want to reason out is doubling of the money. Because the question says, what time will it take for Mr. Adams' investment to be doubled? So you would have to think about it and say, well, what would have caused the money to double? Because when you put down your money, it stays there unless something goes on it. And that thing is called interest. So we're saying that basically then it seems like they're saying to us that how long will it take for the interest to be the same thing as the principal? Because for this money here to be doubled, then I need to get interest of that same amount, 5,000. So indirectly, they are saying to you guys, the interest that they want to work out, how long it will take, is 5,000. Like, how long will it take to make 5,000 interest on that money? And that is how the money would have doubled, because it is 5,000 we put down. So we're saying, oh, so technically when you look at that, you're saying, all right, I have a number of things here. So I want to find the time. You could set up the old formula and work for time. Or you could set up a time formula. The time formula says 100 times I over P times R. That's the time formula. So this is 100 times I, which is 5,000, because that's interest over principal, 5,000, times R, which is 5.4. Let us see what we get. This is suggesting that it's going to take approximately 18.52 years. So this is saying that that's how long it's going to take for that 5,000 to become 10. Basically, that's what they're saying, to become 10, which means that the interest would have been the same thing as the principal. So basically, you know, that's one way you could work. There are many ways to work it. I don't know if I want to do all of them in the interest of time. All right? In the interest of time, I might not just do all of these here. All right, let me show you. I probably just could show you one. All right, I could show you one. All right, I'm just going to show you one more way. All right, I like to give alternate approaches. Another way you could have done it is to understand simple interest. When you understand simple interest, the reason why it's called simple interest is because the interest is the same amount every year. So I'm going to say the interest is the same yearly. So if you make $500 this year in a simple interest agreement from a bank, you're going to make $500 next year just the same. The interest will not change. All right. So we're saying that, okay, that means this person made $810 over 3 years. So then I could say I'm going to divide the 810 by 3 to see how much this person actually made in 1 year. So you divide that 810 by 3, and you're saying that the person is making $270 every year. This is the yearly interest gain. That's the yearly interest gain, you know. So that means what we're saying, you know, in the first year, the Mr. Adams will make $270 on his money. In the second year, he's going to make another $270. And in the third year, another. So he's going to make $270 every year, which means that I could tell how long it's going to take for the $270 to reach $5,000. But I would have to understand that in order for the money to double, the interest must be the same as the principal. So we understand why the 5,000. We are suggesting that if you divide 5,000 now by the interest every year, I tell you, you will get back this exact number. Let's go for that. 5,000 divided by 270, and we're getting the exact 18.52 years. Exactly. All I'm saying is, whichever method you want to use, it's up to you. It's the same thing, right? Take your time, work through. Just take your time and you work through. So that is a simple interest question right there. Simple interest. All right, simple interest. Now we're going on to a measurement question. The measurements questions that comes every year, there are normally some nice workable questions like these. Yeah, there are normally some nice questions. So you have to focus though while getting there. Have to focus as you get there. All right, let us look at it. Let us look at it now. So here it is. This is the first measurement question of the night. And a measurement question is on the paper like this already. So let me tell you, it's on the paper. If it doesn't come in section 1, it will come at number 9. All right. So it comes at number 6 nowadays. All right. It says a farmer Brown make troughs to feed his farm animals using wood that is 5 centimeters thick. That is 5 centimeters thick. As shown in the diagram below. So we're looking at that diagram there. The trough are rectangular base, all right? Rectangular base. So the bottom resembles a rectangle. So you could see a 300 by the 290, which is referring to, so let me just mark this, the 300 by the 290, that's the base, you know, that they're talking about, rectangular. Opened at the top, so at the top it is open. All right, and have an external dimensions as 300 centimeters by 190 centimeters by 160. So they are giving us the things that are actually here. So we're seeing those measurements and we're seeing the thickness of the wood, 5 centimeters thick. All right, let's see the questions now. So that's the instruction, stuff like that. What we want to do now is to look at the, yes. Look at what's going on now. Now let's take our time and look at this. So it says, show by calculation that the internal capacity, which is the volume, same thing, well, technically, yeah, of the trough is 8,091,000. All right, show that the internal, so the focus word here is internal. So we're talking about internal, which means that we have to work out that internal measurement. Now, if there is a thickness of 5, that means there is a thickness of 5 on this side, a thickness of 5 on this side. That means 10 will be subtracted from that. The internal measurement is not like the external measurement because we'll get 10 coming off as a result of the 5 on either sides. Which means that this here is 290 on the inside. So it's 290 centimeters long on the inside. For the 190 here, 5 centimeters would have come off up that end and 5 at the other end. So it's going to be reduced from 190 and it's going to actually reach 180. So this here is 180 cm. Now we have to be very careful with the height, and the reason I'm suggesting that is they told us that it is open at the top. That means there is no thickness from the top, so we're only going to take off the piece at the bottom here. Right here, 5 is going to come off at the bottom. So we're taking 5 from this measurement, leaving it 155 cm. So what I'm suggesting here is that, listen, the internal part of the height is 155. So it's 155. Now we're going to put together the volume and then prove that we'll get that. Remember though that we're working with the internal measurements, the length, the width, and the height inside to get internal. So it's going to be 290 times 180 times 155. Put that on your calculator and definitely you should see that figure coming up, which means that you would have shown them that you are correct. 290 times 180 times 155, and we got it. We got 8,091,000 cm cube. So we got it, right? There it is. So we got that. So we proved that, all right? So let's go to the next question. The next question says, calculate the volume of the wood needed. Now we're going to have to think. They want the volume of the wood that is needed. The volume of the wood needed. Now I want to just take like a minute just to express what does that mean. In other words, if you were supposed to take up that trough in your hand, what you're holding is actually the volume, because the volume is the space occupied. And that is why your hands will not meet, because there will be something between your two hands taking up that space. We want to find the wood that would have made that space. So the wood itself. So a way to do this is to say, look here, the volume of wood. So we want to think about the idea now. The volume of wood is simply the external volume minus the internal volume. So if I find the volume of the outside measurement and then find the volume of the inside measurement, I am going to get the whole thickness, and the whole thickness is actually the wood itself. Therefore, the external measurement would be 300 times 190 times 160. Remember, we have the volume for the internal already, which is 8,091,000. So we got that measurement already. So we will just need to work out the external right there. 300 times 190 times 160. And I'm getting 9,120,000. So I'm getting that. So now I want you to subtract 8,091,000 from that. So we're going to subtract 8,091,000 from that. So it leaves us with the volume of wood needed would be 1,029,000 cm cube. So we need 1,029,000 cm cube of wood to make those troughs. So that's the response. Let's look on that solution there. Yes, all the lives, I just realized all the lives are saved automatically. And there are 5 lives that I have now. And all 5, they're actually there. So you could go back and watch them, it's there. So find them, it's there. It's on the channel. So this is 5 of 5. The other 4 are already there, and this one will be automatically saved when I'm done. All right, let us see what else they have for us. So here it is that we have found out that, hey, we got this to be 1,029,000, right? cm cube. We got that, no problem. That's the volume of wood needed. Now let's go in a little deeper question now. So I'm going to have to go back there, up there to work it out, I believe. It says that Mr. Brown must paint the internal. I want you to pay keen attention because he could have been asked or he could have wanted to paint the external, but he's not painting that. So the question says, Mr. Brown must paint the internal surface of the trough. Given that 1 gallon of paint covers 1 gallon covers 280,000 cm square. 1 gallon of paint covers all of that. So now we know what 1 gallon can paint. 1 gallon paint off all of that. Now we're going to have to think about the internal measurements. So I'm going to go back and let us look. So in order to know, the surface that is going to paint, we're going to have to find the total surface area. You understand? So we're going to find the surface, but the surfaces are rectangular. So if you look at the idea and use a little bit of your imagination, we're talking about the inside part, which means our focus will be on the internal measurement at the end of the day, because those are the measurements. If you should stand in there, those are the measurements you're going to be having access to. Now, I'm going to push the screen to the right a little bit, and then we work out the response to the left. Now, we are suggesting that if you look on the inside, we're talking about a surface here on the inside, and there's a twin for it over there. I'm talking the inside though. So it's going to be a 290 by 155 going up, because going up is 155 now. This is 155 on the inside. Let me put it on the inside too. It's 155 on the inside here. 155 from the inside. So this piece, a rectangle number 1, is going to be that. And there's a twin for it at the back on the other side. If you look over this side here, on the inside here, we're going to get a 180 by 155 over here. We're seeing that. And then, so I could just call that, let me take off this just to highlight it. I could call this internal surface 3, and then there's a twin over here, internal surface 4. So I want us to be thinking like that. And then now on the ground, that the base of it, you're talking the 290 combined with the 180, because that is on the ground. We're not seeing it good, but here's a little pinch of it right there. That's number 5. It's on the ground. I could do a little highlight here so you could have a slight visual of what we're saying there. That part on the ground, number 5. That's what I'm saying, right? Number 5 on the ground will give us that 290 by 180. So let us put the measurements together. The first measurement I want to put together is 1 and 2. We're talking about 290 times 155, right? And then that will be doubling up because it's 2 of it, all right? Plus, we're talking about 180 times 155. And that will be doubling up because it's 2 of it as well. So we're talking 3 and 4 there. Finally, the 5th one is on the ground. It's 290 times 180. And it's all internal. So what we're going to do is just to put our math together. 290 times 155. Multiply that by 2. And we're getting, for this part, I'm getting 89,900 right there. 180 times 155 times 2. I'm getting, we're going to be adding 55,800 there. Plus 290 times 180, and we're getting 52,200. Now, if we put everything together, right? Putting everything together now, 89,900 plus 55,800 plus 52,200. We're looking at a total of 197,900 cm, and it's squared. This is the total interior or the total internal surface. This is the internal surface that he needs to paint. So we have 197,900, right? So now let's go to reason this out where the reasoning ought to be done. 197,900. So I'm going to rewrite that the total surface are in, let me just write in is equal to 197,900. We want to think now, you know. We want to think. What we want to think about now is that they told us that 1 gallon will pay 280,000. This is less than 280,000. So we know that we're not going to even use a gallon to paint this because 1 gallon can paint 280,000 and this is just 197. So what we're suggesting is that if I said the number of gallons, so I want to know the number of gallons. Number of gallons of paint is going to equal to 197,900 divided by 280. Because when I divide this by the 280, I'm going to get how much gallon I need. Because the 280,000 is like saying this is 1 gallon. This is the marker. So now let's see, 197,900 divided by 280, 1, 2, 3. And I'm getting 0.0, no, not 0.0. I'm getting 0.707. This is the amount of gallons, not even 1 gallon. As you can see, it's not 1 gallon, it's 0.70 gallons. That's what we need. Now, the question never wanted the answer in gallon because they said, look here, tell us the amount of paint in liters. Oh, but they told us that 1 gallon is 3.7 liters. Okay. So I know that is less than 3.79. But I'll say to you that the amount of paint in liters is simply equal to 0.707 times 3.79. This is going to tell us how much liters. I'm putting this to 3 significant figures. So I'm looking at 2.68 liters of paint that is needed. There we go. There we go right there. Take a look at it. See how you walk yourself out. These are how, this is how they would normally set that measurement question. All right, so let's look at another question. And this is the observation question. Some people call it problem solving. It comes under the observation section of the syllabus because you're really going to observe this to do it. You're going to watch to see what's going on, you know, to put it together. All right, it says the first 3 figures in a sequence of shapes formed by connecting lines of unit length are shown below. So we're looking at some house-looking shaped ideas, you know, just some house-looking shaped ideas. We have figure 1, figure 2, figure 3. We're looking at those. Figure 1, figure 2, figure 3. And they said draw the draw figure 4 of the pattern in the shape. Now I will say to you when you observe, because I said this topic is called observation. When you do observe this, you're looking at 1 house, 2 houses, 3 houses, and so on and so forth. All right. All right. So here is the deal. All right. So somebody probably some color, man. I don't know. So let's look. So I'm looking at, I'm in my mind now, we're gonna get like 4 of these. So I'm going to just draw it quickly. 1, 2, 3, 4. I think I'm gonna get about 4 of those. I'm trying to just draw it quickly, so we're gonna take up so much time. Like that. So you take your ruler and you draw, just like how I'm drawing right now. You just take your ruler out and you do your nice drawing. You collect your marks. Yeah. Yeah. So as I said, I'm looking for 4 of them. So I'll put 4 there. Based on what I'm seeing, it's gonna be 4. And then I'm just gonna close it down now. So just see with me, I just want it to look neat, like what I'm seeing there. Just want to have it neatly done. Neatly done, you know. So you take your ruler out and we're expecting you to draw it just as how I'm drawing it here. No big deal. Take your time and try to do it to the best of your ability. And we're done. We call it 2 marks. And the grid is there already for you to work within. There it is. At the end. There we go. There's it. All right, so expecting you to do that. And then you would have collected the marks for that. All right. Yes, somebody says 4 houses. You draw it and you move on. Very good, very good, very good, very good. All right, so that's figure 4 right there. Now, after we collect that 2 marks, they are saying to us now, look at the table now. Let me minimize the screen. It says the number of lines L in each shape and the perimeter P of the shapes follow a pattern. Study the pattern of the numbers in each row of the table below and answer the question that follows. Complete the table below, showing the number of lines and the perimeter of each. All right, in other words, when you reach this section, you want to observe carefully what's going on. So I'm going to tell you what to observe. Every time you get a question like this, you're observing the first column here, column 1. There is a direct relationship between column 1 and column 2. There is also a direct relationship between column 1 and column 3. So basically then what I'm going to ask you to do when you see any questions like these is that you definitely want to look at how did the things on column 1 in the same row become the things in column 2 in the same row. For example, we want to figure out how did 1 turn into a 6? How did 1 turn into a 5? How did 2, because the same thing that happened to 1 is the same thing is going to change 2 to 11 and then change 2 to 8, then 3 to 16, then 3 to 11, then 5 to whatever, 5 to whatever. So we're suggesting that is the same thing that will work for each. So let us look. Now, if you observe carefully, you would have seen that 1 times 5 plus 1 give you 6. 2 times 5 plus 1 give you 11. 3 times 5 plus 1 give you 16. Therefore, for this part, it will be 5 times 5 plus 1, and that is going to give me 26. So you notice how I pick up my 26 there easily. I saw the relationship between the first column that says figure with the number of lines L. You multiply the figure by 5 and then add 1, and then you would have gotten the lines needed. So it's looking. Now, we want to figure out what happened for figure 1 to from figure 1 to perimeter. Look carefully. I am seeing here in this row that it would have been 3 times 1 plus 2. That gives the 5. So it's 3 times 1 plus 2. Then for this, I'm seeing 3 times 2 plus 2. 3 times 2 there plus 2. And for this is 3 times 3 plus 2. So basically then, when I'm moving from figure, which is column 1 to column 3, I multiply by 3 and add 2. That means 5 is here. It's going to be 5 times 3 plus 2. And there goes my 17. That is how you have to figure out what's going on. You look and you start to see some pattern going on. And it has to be consistent with every row. So whatever happened in row 1, happened in row 2 and row 3 and so on. Now let's observe this that they gave us here, 66. Now we have 66 and we want to know what is to the right and to the left of 66. I would suggest that we find what is in the figure first. That means I want to know what is in my spot here first. So let's think about it a little bit. Let's think about it just a little bit. If I multiply by 5 and add 1 to get 26, how could I move backwards from 26 to go to 5? Think about it. If you subtract 1 and then divide by 5, 26 turn into 5. That means I'm thinking in reverse. So the fact that I knew how to go forward, then if I think backwards, I would do this. I would say 66, take 1 from it, I will be at 65. And then if I divide it by 5, I get 13. So I'm thinking that, hey, 66, take away 1, that leaves us with the 65. And then if you divide it by the 5, then you're getting the 13. So you're thinking backwards, all right? Then now, if I have the 13, I could go forward because it's going to be 3 times 13 plus 2. And there is my 41. That's how we have to take our time. Navigate and walk through, study, reverse, inverse, stuff like that as you go forward. Now, if you see n, do not be afraid of it. It's the same pattern. For example, for me, it's going to be 5n plus 1 for this column here. In other words, if you just tell me the term, I multiply it by 5 and add 1 to it and tell you the value that you should get. That's what this means. Also, this would have been 3n plus 2, because that is how we did it. We multiply anything in the figure by 3 and add 2 and we reach over there. So we're saying that's how you go forward as well. All right. All right, let's raise this up a little bit. So, all right. So the question says here that, hey, write a simplified expression in terms of n for the difference d between the number of lines and perimeters of any figure. So we want to find the difference between these two things here. We want to find the difference between 5n plus 1 and 3n plus 2. All right, so this one is perimeter P and this one is the number of lines. So we're going to subtract the idea. So basically we'll say 5n plus 1 minus, and I'm going to put this in our bracket, 3n plus 2. Finally, 5n plus 1 minus 3 minus 2. Now, simplifying these, 5n minus 3n would give us 2n, and 1 minus 2 will give me minus 1. And that is a simplified expression for this. Yes, I am. All right, so that's that. That's the observation question, and it is there every year. There are some things that are not there every year, but definitely the observation question is there every year. Comes at number 7. Nowadays. All right. So the next question says the diagram below not drawn to scale. Diagram below not drawn to scale. Shows the triangle MNP in which the angle M, sorry, drinking some water there. In which the triangle MNP, let me read this over. It says the diagram below, not drawn to scale, shows triangle MNP in which the angle MPN equal the angle PMN, which is 52, and MN is 12.5. Sorry about the reading. All right. So basically, you're seeing here an isosceles triangle. State the type of triangle, isosceles. Remember, with isosceles, the prefix iso means same, right? Like in chemistry, some people would have said the isotope of an element. So we're talking about a double thing, they're the same. So what's going on here is that the term isosceles will suggest that we have two same angles which produce two same sides. So for this one, looking at this is an isosceles triangle, and this is how it is spelled. So we have an isosceles triangle right there. No, all right, let's see what is the one. There are some labels I could put on. This side will also be 12.5 centimeters like that. So we have to look forward for those. Determine the value of PNM. Determine the value of PNM. So we're talking about this angle here, and let me mark it nicely. Definitely we could find this angle, man, because there are only 3 angles in a triangle, and we have 2 already. You understand? 3 angles in a triangle, and we have 2 already. So we definitely could put it together to find that, because the total interior angle of a triangle is 180 degrees, which means that this angle here that they're referring to, so angle PNM is going to equal to 180 degrees, and you're going to subtract whatever those 2 angles come up to. So you add them together and take it from it. So that's like, let me just write one more step. And I think this is 52 times 2, 104. So we're talking about having 104 right there. So we're subtracting 104, and so we're leaving that thing with about 76 degrees. All right, so here it is that we found out that that angle that they have there is 76 degrees. I'm going to put it in my triangle though. I want to label that triangle properly so that the next thing that I'm about to do might appear simpler. 76 degrees, that's right there, right? So having had those, we're ready to go. You're ready to go. 76 degrees. Calculate the area of M and P. All right, there's something I want you guys to know. A question like this comes a lot. You can use trigonometry to find the area of triangles. But it works when there is an angle between two sides, right? When there is an angle between two sides, you're talking about the area. This is what they want. So I'm saying to you, if you have a triangle like this, I'm just showing a quick explanation where this angle is at C and this side is at A and this side is at B. And we're suggesting that we know these things, all right, which is this angle there for C. The area of this triangle can be found by just saying half A times B sine C. There is no cosine formula to find area of a triangle. This is area of a triangle. We're not finding a side. We're finding the area of the triangle. So you have to be careful, Chad, when you say cosine there. Remember what they're asking about. The cosine rule is used to find sides and angles. It's not used to find area. All right. So remember, this is area. So we want to make note of this formula in trigonometry, where if you have an angle between two sides, you can find the area of that triangle. Area we're talking. So we could say area, yeah, of triangle MNP is going to equal to. Remember though, based on what we just got, this is the situation we got. So I'm going to quickly give us that situation here. All right, so we have 76 here. We have 12.5 here. And you have 12.5 here. So we are suggesting the fact that we have that in the triangle above. The area is simply half times 12.5 times 12.5 times the sine of that angle. Just get used to that formula. It's going to be very helpful at times. So 12.5 times 12.5, half of that, and then you multiply that by the sine of 76 degrees. Make sure that the calculator is in degrees, and you would have gotten the area. The area of that triangle is 75.8. I think it was centimeter. I'm going to go back to look. Yeah, centimeters. Nice question to work on, but you have to be careful. Understand the difference. This is an area question. Trigonometry has a particular thing you could do to find the area. There it is. All right. Let's go through. I don't know if there's a circle. Somebody's asking about circle. I have circle questions, but I don't have them right now on the board. All right. Hopefully, if we get the time. All right. So this one says the equation of a straight line L is given as 3x minus 4y. 3x minus 4y, right? 3x minus 4y, which is equal to 5. Write the equation of the line L in the form y is equal to mx plus c. All right. Remember, guys, to hit the likes as you come on. So if you're asked to write it in this format, you have 3x minus 4y equal 5. What they really mean is that we want to transpose to make y the subject. We intend to let y be the subject. Y is not, when it is the subject, it's going to be like this. It's alone. So the y is not alone. So we're going to just migrate the things by using mathematical principles anyway. For example, I'm going to subtract 3x from both sides, right? Subtracting 3x from both sides. So I'm going to write back what I have. So when I subtract the 3x from this side, it's gone, but I have to balance, right? So then I have negative 4y on the left side, which is equal to, I'm going to put the x part out front. So I'm going to put the minus 3x first, and then the positive 5 after. So I'm kind of taking the shape like that. Remember now, I need the y to be alone. The y is still not alone. There is a negative 4 multiplying. So what I want to do now is to divide both sides by negative 4. So everything will be divided by negative 4, every single thing. Let me draw a line here. So I'm going to rewrite this negative 4 here would have canceled itself. So I'm left with a positive y now by itself there. And this is going to equal to positive 3/4 with an x. And then this part at the back, don't be confused. The moment you have a plus and a negative, it's going to be automatically a negative. So that's a negative 5/4. There we have it. We wrote it in the form y is equal to mx plus c. So it is y is equal to 3/4 x minus 5/4. Hence, determining the gradient of the line. And the word hence there means that you have to use your last response to answer the question. So this is y equal to 3/4x minus 5/4. And I'm saying that, listen, the gradient is the coefficient of x. So the gradient here, this question, we can just say, listen, the gradient is 3/4. So the gradient is 3/4. The point P with coordinate R2 lies on the line. Determine the value of R. All right, so this is a very nice question here. A very nice question. We're suggesting that whenever we have a line, right? And worse if you have the equation of the line that says y is equal to 3/4x minus 5/4. That's what the equation, that's what it says, right? So they said there's a point on that line, right? R with 2 at the back. And they're saying, listen, determine the value of R. If that is the case, you could go for any one of these. You could go for 3x minus 4y equal 5. Because remember, I know, it's the same thing. This is the same thing as 3x minus 4y equal 5. So we wrote it like this for them. We wrote it like this because they asked us to. But it is the same thing here. If you want to work out any point that is on any line, the equation of the line will help you. So I'm going to use the easier form like 3x minus 4y equal 5. If I'm working with R and 2, if I plug in the 2 for y, then I can find the x, because this is an x value and this is a y value. They walk together. So because they're on this line here, they're on that line, I could substitute the 2 where y is, and then it's going to tell me the value for x, which is a r. So then we could say 3x minus 4 times 2 equal 5. Because it's going to be 4. This is 4 times y. So it's a 4 times 2. So what are we looking at? We're looking at 3x minus 8 equal 5. We're trying to find the matching coordinate for it. Add 8, add 8. 3x is equal to 13. Divide by 3, divide by 3. X is 13/3. That value is the R value there. So we could just conclude and say the R value is 13/3. That's the principle. That is the principle. So what we're saying is that if a point is on a line and you know the equation, you can substitute any value and it's going to give you the next one. That is how unique the idea is. So this is telling us that when the y value is 2, the x value is 13/3. That's what that means. The next question says, find the equation of the straight line passing through the point 6, 0, which is perpendicular to L. All right, now let's go and look at this idea. If it is perpendicular to L, you need to see L. L is that same thing that we found earlier. So the equation, so L, the gradient for L, so I'm going to write L's gradient was equal to 3/4. When lines are perpendicular, one of them gradient is the negative reciprocal of the other, which means that if L's gradient is 3/5 or 3/4, the perpendicular line to L gradient is -4/3. So we are suggesting that if L's gradient is 3/4, any line perpendicular to L would have, you flip the thing and turn it, so you turn it upside down and change the sign. Some people always ask some question like, sir, both of them positive, so both of them should be negative. No, this is a fraction. So what I'm suggesting, let me put it way out front so that you could see. It's a fraction. So the negative sign is not on the 4 or the 3. It's the fraction that is a negative. This is a positive number. It's one number. It's singular. So then this is a negative number. It's one number. It is called -4/3. All right. So that is the gradient, and this is the point that it passed through. Yeah. That's a gradient and that's a point that it passed through. So what we want to do is to write the equation. Remember, you can write the equation of a line if you have the gradient and the point. So you could find your C value, if you want. There are many ways to do it. Or you could put it in a point slope form. Remember, so this is like x1, y1. The point slope form says y minus y1 is equal to m open bracket x minus x1. This idea is called when you have a point and a slope. So they call it point slope form. Slope means gradient. So point and a gradient, you could put it in this and then get the equation of the line very easily. So we're talking about y minus y1, which is 0, see it there, is equal to m, which is -4/3 open bracket, x minus x1, which is 6. So y minus 0 is still y. We're going to distribute. We want to distribute this inside the bracket here. All right. So we're going to get -4/3 x. And then when the -4/3 class with the -6, it becomes +4/3 times 6. So negative and negative here turns into positive there. And if you look carefully, their canceling can go on because 3 into itself one time, 3 into 6, 2. So the final thing is y is equal to -4/3 x plus 8. And there you go. that would be the equation of the perpendicular line that they mentioned here. So I want us to look at that. Coordinate geometry is on the paper every year. We don't know how they'll send it. They could send it like the ones we did yesterday, or they could send it like these. We don't know how, but definitely it's on the paper. Right? All right, so we're in some trigonometry now. All right, so we're moving all over the paper, trying to go through various things that we know will show up. So trigonometry is one of those things that comes a lot. So let us look at this diagram. It is one of those depression angle thing that we got here. All right, let me minimize this a little bit more for reading purposes. So it reads, it says a person at the top of a lighthouse TP. So look at the diagram, you're seeing that. Sees two ships, it's S1 and S2, we're seeing those. All right, so we're talking about T, P, TD, S1, S2, we're seeing those. All right, approaching the coast as illustrated in the diagram below, the angles of depressions are 12 and 20 degrees respectively. All right, so the ships are actually 110 meters apart. So we know the distance apart. We want to put that, I want to put this distance here. It's 110 apart. So they're telling us that, listen, 110 apart. I don't like how that looks. So 110 meters apart between them, no problem. All right, let's go. So the question says, complete the diagram below by inserting the angles of depression and the distance between the ships. So I just put the distance between the ships here. The depression angle, this is an horizontal line. This is coming from, this is actually coming from your eye level up there. You're standing up there looking down at two things. So that's this horizontal line is your eye level, and the angle of depression will be between that. So there is an angle between this to this line that leads to S2, and there is an angle, a bigger angle between that and S1. So you can see the bigger angle must be that bigger number, right? So we want to look at it like, okay, so the smaller angle has to be 12 and the bigger angle has to be 20. Even if you never knew, has to be, right? Also, so this is the diagram here. But what I normally do is just to go and help myself quickly by putting some measurements in the triangle, because this line here, if you walk it down, here, the 20 is going to be down here as well. How do I know? Because the 20 degrees is linked to this line. You could see that that's why it touches it. 20 degrees is linked to that line. So what you want to do is that you want to put the 20 down here as well, here. And this is for the working now. And then the 12 is going to be down here. So the 12 will be down here as well. All right. 12 will be down there. So those are some information that we have, and we want to go forward now in solving. Determine to the nearest meter. All right. If you notice too, you know, this little angle here between this, if you're thinking this little piece here is 8, you know, that little piece is 8. So if you look at it, you're seeing that, yes, that little piece is 8 right there. So determine the nearest meter, the distance T, where is T? T, oh, the distance T S2. So this is S2 out here. This is S2 out there. All right. Between the top of the lighthouse and the ship. S2. So between the top of the lighthouse and the ship, S2. So it said determine that distance there right about now. So what you're going to do, let me help you to think. Let me see if I can, all right, you see the question big enough. What I did here was I show you that, hey, this little angle between this little piece of angle here, it's very little right there, is 8. So if you look at the triangle and this is 8, this is the opposite side for it, you know. Yes, man, that's the opposite side for it. And then now, they're asking me to find this. But I can find the opposite angle because if I have 20 here, that means this is 160 here. Because 160 and the 20 will give 180. So when you really look at that triangle, you know, I'm focusing on T. I'm going to draw it bigger for you because that one is not as big. So I'm doing it big. This is 8 up here. This is S1. This is S2. I am saying that this is 60. No, because on the outside was 20. So I could come on the inside with a straight angle. So they're asked, so no, this is 110. And they're asking me to find that. So you could see we could use the sine rule because this and that are opposite to each other. The 160 and that they asked us to find. So that's the explanation I'm giving there. So you could feel a little bit comfortable to see, because when you decorate the diagram, sometimes it's very hard to see on it. All right, but I hope that will be clear enough, as you could see right there. All right, so let's put it together. We're suggesting here that we want to use A over the sine of A, which is equal to B over the sine of B. A, 110 over the sine of 8 degrees, and this is equal to T S2 that they asked us to find over the sine of 160. So it says the distance TSC between the top of the top of the thing on the shape. So there it is. We're going to set up this. So at this time, what we want to use now is cross multiplication. 8 times that is equal to 110 times the sine of 160. So we're going to set up that. So we could set it up and say, all right, TS2 times the sine of 8 degrees is equal to 110 times the sine of 160. And then if I want to find TS2, I'm going to divide by this now. As you could see, divide both sides by the sine of 8 degrees. And now you see that the TSD is by itself. So now we could just put this on our calculator and get the value for that, the length of that side over there. So 110 sine 160. You want to divide that by the sine of 8. And that is giving me some, this is 270.3. The question says to the nearest meter, so it is going to be 270 meters. That is the length of that side over there. And that's what we're suggesting. So some of the times you just have to look. There are various levels of difficulty as it relates to the questions. So that one, that's how they pull that one off. But you have to be thinking, all right? Thinking about what you want, fix it up, and you go. The height of the lighthouse, TP. So now they want us to find the height. Well, you could find the height, right? In finding the height, I would suggest that you focus on the very big triangle. All right, let me put it, where do I put this? Let's push it to the side. Focus on the big triangle to find the height. And what do I mean? Here is the big triangle. There is a 12-degree angle here. There is 270 here. There is 90 here. And this is T and this is B. And the intention is to find TB. So I'm just saying that with that said, I would be using the sine ratio because I would want to find the opposite side, but I have the hypotenuse to there. So then all we're going to do is just to say, all right, the sine of 12 sine of 12 degrees is equal to opposite side, which is the TB that I want to find, divided by the 270. And we're done. Because all we're going to do is to multiply both sides by 270 so that I could cancel that on the right side. And then now on the left side, we're talking 270 sine of 12, right? 270 the sine of 12. And we're looking at TB to give you about 56.1. All right, 56.1 meters. So that would have been TB. We want to look to make sure. So this is 56.1 meters. But they did not ask for any special rounding off, so we're good. So I hope you look at how you can pull your diagram apart. Pull your diagram apart, man, and do what you have to do with the knowledge you have. All right. All right, let's take a re-explanation of this one now. Then I could just go to the working. So I'm going to be talking back through because I know sometimes when they come like this, some people struggle. All right, so this one says that when you read the information, it's on the diagram here. So we have S2, S1, and somebody's standing up here looking down. So we're dealing with the angle of depression. Somebody was standing up here looking down. So then we're saying that the person look at S2 and look at S1. And they gave us the angles to be 12 and 20. The angle of depression is between the horizontal line, which is what I highlighted at the top, and the line you're looking along to see the thing. Hence, we have one here at 12, and we have another line at 20, angle at 20. The bigger one has to be 20 and the smaller one 12. I want you to also understand that these two angles up here, they have a value in the triangle as well. So you could follow the line that the angle stop on to see where you're going to mark the angle in the triangle. So if you look 12, when I follow the 12 degrees here, it came to this corner here. And when I follow the 20, it came to that corner here. You could see that following the lines that they are attached to. Then now, I am saying to you that there is a difference between where 12 stop and where 20 stop is 8, because 20 minus the 12 is 8. So we are saying this little piece of angle here is 8 degrees that I highlighted here in blue. In there is just 8 degrees. Also, since you knew that this is 20, then you have the ability to come across on the inside of the triangle by taking it from 180 over here is 60. Why did I try to find those? I had to find those because they want us to find this length. they want us to find this. And when you look at it, you didn't have any measurement to find it. But you could come inside here, yeah, utilize this. Well, not that, we're not using the 12 there, I meant. Utilizing the 8 up here and the 110, because the 110 is actually fully opposite to it. And the 160 is opposite to this. But remember, there was no value there. So at that time we said, oh, we can use the A over sine A is equal to B over sine B. So then this principle is based on an angle and the opposite side to it. But they will always give you an angle and the opposite side already, and then give you an angle and ask you to find a side across it. Or give you the side and then ask you to find the angle across it. In this case, we were able to get the angle based on previous knowledge. We were able to get the angle and then we are searching for the side. Thus, we set up A over sine A equal B over sine B. So 110 over the sine of 8. See it here? The 8 is opposite to this side. And that is why I drew a diagram separately. So I said, look at this diagram. The 8, so I draw it bigger. The 8 is opposite to that. That means the formula says put the 110 over the sine of 8, and then you're going to put the side that you want to find. No, which is x over the 160. That's the sine rule. Hence, I end up with that. But I did not call it x, I call it TS2 because that's what they asked. Then now we cross multiply. So when you cross multiply, you're no longer dealing with trigs, you're just solving the problem. We end up getting TS2 sine of 8 is equal to 10 times the sine of 160. Then we divide both sides by sine of 8 to balance, divide. And then the rest is your calculator. Just that you understood that, we're moving forward. All right. All right, let's look at this other question now. Let's take some time, look at this other question. All right, so this question says, the diagram below, not drawn to scale, shows a hollow cylinder with 8 cm height and the diameter 12. Calculate for the cylinder the radius. Remember, they gave us the diameter, and we have 2 radii that make 1 diameter. So having a 12 here, radius is equal to 12 divided by 2, and we get 6. That's the unit. So the radius is 6. The circumference of this, the cross section. What is a cross section? A cross section is a uniform shape that exists throughout. Cross section is a uniform shape that exists throughout, meaning down here is a circular thing. This is the cross section. That is why you're seeing it at the top. So it is a uniform shape that exists throughout. So when they say, calculate for the cylinder, the circumference of the cross section, all they are saying, calculate the circumference of the circle. Remember that we have the radius. What is circumference? circumference C is equal to 2 pi r. Or you could say pi d, which is the pi times the diameter. So it's going to be anyone you want to find. So I'm just going to say pi d. So it is pi, which is 3.14. They told us to use pi as that, times the diameter, which is 12. So 3.14 times 12, and we're getting 37.68. So this is 37.68 centimeters. So that is the circumference. All right. All right, so we're looking at that 37.68. Pi times diameter I use here. What if you wanted to use 2 pi r? So I'll show you that is the same response. Circumference can be found by using 2 pi r, which is 2 times 3.14 times r, which is 6. And do that, you realize you get back the 37.68. So we can use this if we want, or that. For circumference, we will get the same thing. Now, the question pushed further and it says, guess what? The rectangle shown, not drawn to scale, represents the net. The net means something that is used to form the thing. So the net is the development of something that is used to form the shape or the solid. So it's like a fowler leaf and you can turn it into a cylinder. Imagine that you have a fowler leaf and you can always just turn that fowler leaf into a cylinder. So that's what this is saying. Imagine that this piece of paper here is a cylinder. So if you have your cylinder like that, you imagine that you open it out, it's going to look like this. And that's what they're saying. It's going to look like that if you open it out, right? So imagine that you cut it with a scissors and just open it out, it looks like that. So they are saying that state the values of A and B. The height is going to be B for me. The height is B. So this is 8. And then remember, if you look good, when you find the circumference, you actually find the distance along the circle here. Circumference, distance along. So if I should open out that there, this would be my circumference, that yellow. Imagine I bend this around, it will turn the circle. Think of A being bent around like you have a fowler leaf and you turn like that, and then you bend it around, you realize that that yellow part, all of those yellow parts will be a circle at the top and a circle at the bottom, basically. So that's why I said that we're using the B as the height. And when you bend it around, you're getting that. So that's what we have there. So remember, we just found the circumference to be 37. So I'm saying A is 37.68 and B is 8. All right? So we're talking about same, right? I think centimeters we have there. Yeah. So it is the circumference, that is the yellow part, and the height is 8. All right? So I was just suggesting that this, when you open it out, there's a circle down there, and that's the circumference. So when you open it out, we're looking at that yellow thing that we have up top. All right? All right. Now, let's look at what else they want. So now we have that they said, hence, calculate the area of the curved surface. Okay. So if I know that A is 37.68 and B is 8, area of this is length times width, which is equal to 37.68 times 8. So you just multiply normal, don't think of anything extraordinary, and you will get 301.44. Right? 301.44, and that is the area of the curved surface, which was that thing that we looked at. If 0.5 liters of water is poured into the cylinder, calculate correct to 1 decimal place the height of the cylinder, the water and the cylinder. So they are saying they're going to throw. So you're going to throw some water in this, so it's going to go somewhere up. So it's going to move somewhere up. So water going to this, it has some height somewhere. We were told what was in there though. We're told how much water was thrown in there. They said is 0.5 liter. We cannot work with liter and centimeters. All right. So what we want to do is to we want to convert this, because the liter, you know, when we convert it to, we want to find a relationship between liters and centimeter cube. And then if this is thrown in there, this is like the volume you're looking at. So we will be able to tell the volume, this is the volume of water in there, but it is in a unit that we can't work with. So I will say to you, because you don't get this from CXC, that 1,000, you can make a note of it, cm cube, which is the volume idea, is equal to 1 liter. 1,000 cm cube is equal to 1 liter. Let's check it out again. 1,000 cm cube gives us 1 single liter. Yep. So then you would, if you look at this, all you have to do is to multiply by 1,000, right? So then if we multiply 0.5 liters, if I multiply that by 1,000, I'll get the amount of water in centimeter cube. So this is the water in centimeter cube that is equivalent to half of a liter. 1 liter is 1,000 cm cube. So if you have half of a liter, if you think about it, you would realize that it is 500 cm cube of water in here. So I'm going to put it in here. It's 500 cm cube of water that is actually in that container. If we want to know how far up it goes, we will have to find the area of the circle and divide it into the volume of water in the tank. The area of the circle, we want to use that to divide into, all right, the area of the circle. So let's get the area of the circle first. We need the area of the circle to know the height, because we want to find how far up the water is in the tank. So let us quickly go for the area of the circle. Area of the circle, remember the radius was 6. So area of the circle, area of the circle is equal to pi r square, which is equal to 3.14 times 6 square, pi r square. Put this on our calculator. All right. 3.14 times 6 square. And we're going to get 113.04. This is the area of the circle. So what I'm suggesting to you, all of the water in this container here is 500 cm cube. But remember, if you throw the water, it has to actually the water has to actually fill out this first. Imagine it with the water in the container. It's going to fill out the bottom first before it starts to rise up. So it's going to cover the bottom of the container, which is the area, and then it starts to rise up over time. So so what we're suggesting is that this 500 cm cube, if you divide this by the area of the circle, which is the base, it's going to tell you how far up it goes. So 500 divided by 113.0 is equal to 4.42 centimeters. So I am suggesting to you that, listen, this that we have here, we're saying that the height is 4.42 when you have 500 cm cube of water in this container. This is how far it goes up in the container, 4.42 centimeters. All right. All right. That's what 2 hours allows us to do. That's what 2 hours actually allows us to do, guys. I have a lot of questions, but 2 hours is just 2 hours. All right. So we just had to do what we have to do and stop where we have to stop. I'll say this to you now. The exam is the day after tomorrow. Get a 3B pencil, find a way to get a 3B pencil to use. If not, then use what you have. But I'm telling you, the right pencil that CXC requires is a 3B. And make sure that you have your IDs. For those of you who are going to school, your school ID should work. And if you're not going to school, it's a regular ID like a passport, driver's license, or your voter's ID are what they actually accept at the centers. All right. So, yes, Leon, you actually could do anything you want to do now. As soon as I close the live, it's automatically saved, so you can actually rewatch the video, do anything. It's gonna be a normal video on YouTube where you could go forward and backward when you're ready. So as soon as we close this, it becomes automatically a regular video on YouTube, right? All right, guys. So basically, this is at the end of the session. I will be still in WhatsApp. I will be there. For those of you who have links to me, I will be still around. We have a day, 2 days to go. And I wish everybody the best. And I know everybody will perform up to scratch. So enjoy the rest of your evening, guys, and continue to study. All right? So wish you all the best on Wednesday. All right, guys, we're closing this live.